Okay, so in example 4 here, it wants us to factor completely. And so you got to remember your rules of factoring. So remember, you start out looking for a greatest common factor, and then we're going to count the number of terms. If there's 2 terms, it could be a difference of squares, or it could be a sum or difference of cubes. If there's 3 terms, there's the what I call the simple way to factor it, if there's a 1 at the very front, or the alien if there's a 2, or that's where you multiply the first times the last. And if there are 4 terms, then you're going to use grouping. So you got to remember your rules of factoring in order to do this. So look at A here. It says we got 2 sine squared minus 2 sine squared of x minus 3 sine of x plus 1. Well, this is very similar to if I had written 2x squared minus 3x plus 1. Could you factor what I wrote there on the right? Yes, you would take your first times your last here. And so you'd have x squared minus 3x plus, remember they multiply, so that's a 2. And then we would factor this simple trinomial. So x and x, and we're after 2 numbers, so they're going to multiply to 2 that will add to 3, which is 2 and 1. Always put my bigger number first, so I'm bringing down that first sign. And a negative 2 times what kind of 1 is going to give me that positive 2 when I multiply them? Well, it's going to have to be a negative. But don't forget, because you multiply at the beginning, you got to divide here at the end. And so we get x minus 1, because it reduces, but the 1 over 2 doesn't reduce. And remember, because we're only factoring, you have to put the 2 back in front. So you're going to throw the number on bottom in front of that x there, okay, to have it factored completely. You can't leave a fraction in a factor, so don't leave it as x minus 1/2. That's not okay. Alright, but remember in our problem here, we didn't really have an x. What did we have in the middle there? It wasn't just 3x, it was 3 sine of x. So that means that when I factored this out, I'm going to get, instead of x minus 1, it's going to be sine of x minus 1. And instead of 2x minus 1, it's going to be 2 sine of x minus 1. And so here is my factors. I can't factor either one of those any further. So that's all I can do as far as factoring. Alright, moving on to B. Look at B. It has no greatest common factor and it's 2 terms. So I know it's either going to be a difference of squares or sum or difference of cubes. I notice it's a difference, and 16 and secant squared both have square roots. So this is the difference of squares. So remember, when we're factoring a difference of squares, we're going to have 2 parentheses. One's going to have a plus and one's going to have a minus in it. And then you just take the square root of them. What is the square root of the 16? Well, it's 4. 16's at the front, so we're going to put 4 at the front. What's the square root of secant squared? Well, it's secant. Secant squared's at the back, so secant's going to go at the back of both parentheses. I didn't leave myself much room there. And then check and make sure you can't factor them any further. Can't do anything there. I can't do anything there because even though 4 has a square root, secant does not have a square root. So that means this is factored completely. So for C, remember your first step is greatest common factor. We have 2 terms here. Do they have anything in common? They do. They both have a cosecant of alpha. So we're going to take that out. So we got cosecant alpha times. When I take this out, it cancels, so I'm left with a 1 minus, and I take that out, and I'm left with cosine squared of alpha. Now, are we done factoring? Remember, the rules are here to factor, because now 1 minus cosine squared is an identity, but it didn't say to use identities here, it said to factor. So can I factor this any further? Well, yeah, I notice it's 2 terms with a minus sign, so I'm thinking, is it a difference of squares or a difference of cubes? Well, does 1 have a square root? Yes. Does cosine squared have a square root? Yes. So it's a difference of squares. So we're going to bring down this cosecant of alpha because we can't do anything with it. And then when we factor this, we know difference of squares. It's just like what we did in B above there. We're going to have 2 parentheses. One's going to have a plus, one's going to have a minus. Take the square root of the first one, so the 1, which is 1. So it goes first. Take the square root of the second part. Square root of cosine squared is cosine. So it goes second. And don't forget to put alpha with it. And then check and make sure you can't factor anything else, and you cannot. So this is completely factored. Then for D, we have cosecant squared of beta minus cotangent of beta minus 3. So it gives us the idea that it's going to be a trinomial. The only problem is I don't have the same type of a trig function. Like in A, we had a sine squared and a sine. In D, here we have a cosecant squared and a cotangent. So they have to be the same in order to factor them. So I need to find a way to change cosecant squared to cotangent, or cotangent to cosecant. Now, cotangent to cosecant, there's no rule for that one. But when I see the square on that cosecant squared, I know I've got those Pythagorean identities, which could help me change it. So, let's look and see what that Pythagorean identity was. So let's go back in our notes here. Let me go through mine. And I see the one that has cosecant squared in it. Says 1 plus cotangent squared, equals cosecant squared. Well, that's what we needed, because we needed to be able to change cosecant squared into a cotangent. And we know that cosecant squared is equal to the 1 plus cotangent squared. Since they're equal, I'm just going to substitute it in. So cosecant squared is 1 plus cotangent squared of beta, and then minus cotangent of beta minus 3. Now, there's nothing in front of the parentheses there, so I really didn't have to put it. I just wanted you to see that cosecant squared of beta is that 1 plus cotangent squared of beta. So we've got 1 plus cotangent squared of beta minus cotangent of beta minus 3. I'm going to combine like terms here and write my trig functions in descending order of their exponents. So we get cotangent squared of beta minus cotangent of beta, and 1 minus 3 is negative 2. And then we can factor that. This is just like if I had, let's see, instead of putting all these cotangents and stuff, if I let cotangent of beta be my x, I could say this is x squared minus x minus 2, and just factor that. And so instead of factoring it over there with the x, I'm going to do it over here on the left with the cotangents. So we know that those first terms have to multiply to give me cotangent squared. So it's going to have to be cotangent times itself. And we know our last two numbers are going to multiply to 2 and subtract to the 1 in front right there. So that's going to be 2 and 1. So this is going to be a minus, so bring down my sign, and negative 2 times what kind of 1 gives me a negative 2? A positive 1. Now this wasn't one where we had to multiply at the beginning, so we don't have to divide at the end by anything. Just check, can you factor those factors any further? And you cannot, so this is completely factored.